Good morning all and welcome to MultiKV's Electronics Lab. Today we will have a look at a nice little power supply. To be more precise, it's a DC buck converter. It's the model DPS5020, produced in China by Ruiding, and it's capable of delivering 50 volts output at up to 20 amps and can handle up to 60 volts input. So I think this is a nice device. I was looking for something I could use as a solar charge controller for 2 solar panels in series, and this would give a open circuit voltage of up to 48 volts, and most of the DC converters are only able to handle up to 40 volts at the input. And here is my test scenario. We will look at today. I have a big server power supply. It can deliver up to 6,000 watts. Have a look at the specifications, and we will only need 1,000 watts because the buck converter can deliver 1,000 watts, so this would be no problem for this supply. And we have another DIY bench power supply made of traditional transformers and bridge rectifier and smoothing capacitors. It's made of one big variac which drives 2 toroidal transformers. On the left hand side there is one that can deliver 30 volts at up to 28 amps, and on the right hand side we have another toroidal transformer of 800 watt power that can deliver up to 50 volts AC at max 16 amps. So this would be a nice supply as well for testing this little device. And here on the right hand side I have made a DIY big resistive load. It is constructed from Cantal wire, a square diameter. It's 2.5 millimeters by 0.5 millimeters, and each meter has around 1 ohm, and it's 6 meters connected together, so I have 6 ohm in series, and is capable of holding up to 20 amps for a little while. But we will use it only at around 10 amps. And here's another resistive load made of nichrome spirals. Each spiral is 1.5 ohm. And here I put 3 spirals in series to give us 4.5 ohm. And I put 2 of these packs in parallel, so we have 2.25 ohm here. And I configured this one to be 4 ohm and 2 ohm, and I put the 2 ohm with this load in series, so we have 4 ohm and 4.25 ohm in parallel. That would give us around about 2.15 ohm total. Just to check the max current capability of this power supply, which is 20 amps, and this is quite a lot for this little device, which came in this cute box you can see here. It's a styrofoam box together with 2 little cards. One is for Bluetooth connection, the other is for USB connection with your PC. And there is a software downloadable where you can use to operate this buck regulator with a PC. It's very nice. You can set a lot of voltages and max current, and control a lot of parameters just by the PC. And now I'm going to put the camera on a tripod and we will do some load tests, measuring the accuracy of the device. I already did some tests, and to be honest, it's very precise. It's a very smart little device. It shows a lot of values. So this is the setup for measurements. I've also put a scope meter, the Fluke 123, here for measuring the ripple at the output of the buck regulator. And we will now try it with a heavy load. I will switch on the server power supply. I'm afraid the fan makes a lot of noise, so be prepared for this. And we will see the thing switched on. So the server is coming up and you can see the values. I have set here the max voltage to 41 volts output, the max current to 20 amps, which is the maximum the device can handle. Right now we have an input from the server power supply of 48.6 volts. I hope you can see it. I can adjust the input voltage here with a little 10-turn trim pot on the power supply. I have made it adjustable. It normally delivers 42 volts, but I have made it adjustable to from 36 to 52 volts, which is the maximum. Afterwards the overvoltage protection kicks in, and below 36 the undervoltage protection kicks in. So it's a nice area from 36 to 52 volts, and it can deliver up to 140 amps, which is too much. So I put it to 50 volts now. This will be enough. Here on this Fluke DMM you will see the output voltage of the buck regulator, measured right at the output, and here is the input current from the server power supply to the buck regulator, so we can calculate the efficiency of the device. So I will now switch the output on and we will have a lot of load. You can see here we have 800 watts of power, 20 amps output. You can see the voltage measured here. We have 40.8 volts at the output, 40.9, and we have 40.98 measured here by the device. The fan is running at high speed now of the little device to cool the MOSFETs and the diodes, and we will wait for a little while. Oh, we have over voltage here. I put it on 2 amps. That's wrong. I have to put it on 20 amps and DC. So we have 16.26 amps input, 19.3 amps output at 41 volts. And we will see, you can already feel the heat of the resistive loads here. It's getting quite warm. The right one not so much, but this is getting quite warm. And we will also test the temperature of the little heatsink here. It's not really getting warm right now. All the capacitors are cool. The coil keeps cool as well. So this is very nice. It's starting to get a little warm. This is not surprisingly at 20 amps, and we will have a look at the output ripple. It's getting really warm now here. So at 20 amps we have a ripple of only 35 to 36 volts. I don't know if you can see this here on the right. I think the light is not good. I'll try it like this. This is the output ripple. This is not much, 35 millivolts, 35 millivolts at 20 amps output. This is a very good result, I would say. Most buck regulators at this current have much more ripple. It goes into the hundreds of millivolts, 500, even 1 volt of ripple at the output. So I will test the temperature. The fan kicks in at 10 amps, but still just hand warm, a little more, maybe 40 degrees centigrade at the heatsink. This is nice. The coil keeps cool as well. Output capacitors are cool. Input capacitors are cool. Probably this shunts getting hot. Can I touch them? No, they're quite hot. They have the maximum current they can hold now. I can touch them, but I think they are around 50 or 60 degrees. The current is decreasing. No, it's not decreasing. We have 19.23 amps at the output, and we have 16.09 amps at the input. Input voltage is 49.57, and output voltage is nearly 41 volts. I will adjust the input to 50. So now we have exactly 50 volts input. Little less than 16 amps input current, and still 19.22 amps output at 41 volts. Let's do a temperature test just by hand. Still nice to touch, not really hot. It's more hot at the corner of the left top side. It's cooler on the right side, but I would say it's around 40-45 degrees centigrade. Coil is still cool. Output capacitors are very cool. Input capacitors starting to get a little warm, but not really much. The resistive loads are very hot now. Not glowing, but making this little room, this little workshop quite warm now. I can adjust the voltage here just by pushing the V button and turning the wheel. Now we have 40 volts, 39, 38, 35 volts. You can see the set voltage is 36. Now we have 36 volts at 16.9 amps. And when we go up, we can set it to now we have the maximum amps reached, so we are in constant current mode, as you can see here by this sign. Output is okay, output is activated, and we are delivering 855 watts right now. So input voltage is at 49.96. I adjust this to, it's exactly 50 volts now. And we have an input current of 17.28 amps, output of 20 amps, output of 42.87 volts. So this is the maximum load I can deliver with the resistive loads, and it's not really getting warmer. It's very okay. I would say below 50 degrees definitely. 40 to 45 probably. The coil is getting slightly warm now. Output capacitors are cool. Input capacitors nearly cool. One thing I just see, the vents of the heatsink are blowing directly to the input capacitors. This is probably not optimal, but no problem so far, as they stay quite cool. And this is the max load, it's 20 amps, and I would hardly use that much power often. So I'm very happy with this device. It stays cool. Oh, it's not getting much warmer. The coil is getting a little warm, but it's around 35 to 40 degrees, I would say. So all in all, I'm very happy, and it seems very precise. When we look at the voltage, it's 42.65, 42.7 now, 42.7. This is exactly, very exactly at this high load. I'm measuring directly at the output, but the shunts and everything is probably more inside, so there are some losses at this high current. If I go down with the current, let's set the current down with the constant current activated. I put it to, let's say, 1 amp, and we have 2.13 volts at the output, 2.12, it's very, very similar. I think it's changing a little bit because the resistive load is not constant, because the nichrome wire changes the resistance with high temperature. It gets higher resistance. When it's cooling down, it gets a lower resistance. So the values are changing a little bit. Now we deliver only 0.26 amps in at 50.4 volts, and delivering at the output 2 volts 1 amp. So I'm pulling it a little more up. You see now the fan of the heatsink has stopped. It's very cool now. I adjust the max current setting here and climb up. 3 amps, 4 amps, 5 amps, 6 amps, 7, 8, 10 amps now. You see the fan is just starting at 10 amps. And we have 20.1 volts output, and we have here 20.1 as well, 20.2, 20.2, so that's very precise. We have 10 amps output, 202 watts, 4 amps point 2 going in at 50.36 volts. And we can climb up more. If you push this button, you can adjust also the decimals of the current setting. You can go to the first decimal or second decimal by just pushing the button. I can show it. Now we can change the in 100 milliamps steps. Oh, we're already 20. No, I was going to the 10. Now we're in the 10 milliamp steps. I can go down here. So we have exactly 20 amps now. And if I push again, I'm on the 100 milliamps, and if I push again, I'm on the single amp step. So we have 20 amps at 42 volts output, delivering 847 watt, 17.08 amps input at exactly 50 volts in. I will calculate the efficiency afterwards and show you the results. So now we have 42.45 volts, 42.5. So this is very precise. This Fluke DMM 189 is very precise. So yes, very cute and smart little display with very high accuracy. I think that's it for now. I will do some more tests soon, but for now I think it's enough. It holds the power, it delivers what it claims. We are now at 850 watts and the heatsink is just hand warm, maybe 40 degrees. Coil is cool, input capacitors stay cool, output capacitors cool right now. So I'm very positively surprised. Thank you for watching and hope to see you soon. Now I have reconfigured the resistive load. I put each of the 6 1 ohm resistors in parallel. So I connected the upper row with a bus bar, and I connected the lower row of the inputs with a bus bar. So between them I have now 6 ohm in parallel, which would give us 1 divided by 6 ohm, round about 0.166 as a resistive value. So we can test now how the buck regulator can deal with high currents at a very low voltage, which will probably be some problem. But normal buck regulators start the output at 1.2, 1.3 volts. This one just can start right at 0. So we will see how it can deliver high currents at low voltage. So I set the output to 1 volt now, and we have a current of 4.5. I measure 0.96 volts with a Fluke, and here it says 0.99 volts. We have an input current of only 0.13 volt at 50.5 volts input. So let's increase the voltage. Now we have 2 volts input at 9.23 9.4 amps output. Something's getting warm. No, not now. Not yet. So we have a very high current at a very low voltage setting. Adjust it a little bit so it is better. And we will increase the voltage by 1 volt. This. Now the fan kicks in. We have 14 amps, 14.5 amps at the output, 3 volts at the output. So very low voltage, very high current. We have 1 amp input current and we have 50.44 volts at the input. The heatsink stays cool. Input capacitors coil are very cool. This is also cool because it's low current on each wire. So we still go 1 step up with the voltage. Now we have 4 volts nearly at the output, nearly 20 amp, 19.4 amps at the output, at only 4 volts at the output. We have 1.81 amps at the input and 50.4 volts input. Heatsink is still cool. Capacitors are cool. Coil is cool. Everything works fine. Now let's see how deep we can go with the voltage. I go to the voltage setting. 3 volt. Can you see? 2 volts. 1 volt. And I click here to go to the 100 millivolt settings. Now we have 700 millivolts at the output at 3.3 amps. Everything works fine. It shows 0.69, 0.67, and go further down here. Where are we? We are at the top level. I have to now voltage and so the 100 millivolt steps. Now we're at 0.5 volts, 2.37 amps output. The heatsink is getting slightly warm. Interesting. Capacitor is cool, coil is cool. We deliver only 1.16 watt. Have an input current of only 70 milliamps now at 50.48 volts. I adjust the input voltage to 50 volts now. So we have exactly 50 volts. Heatsink is cool. And we can go further down to only 200 millivolts at nearly 1 amp output, and further down 10 millivolts or 90 millivolts. This shows around 80 millivolts at half an amp. No problem whatsoever. So we will increase the voltage now to full 1 volt. Go 1 step up so that we have full volts. I will go step down to We have exactly 1 volt now, and step up again, 2 volts, 9.7 amps output. The fan is still off of the heatsink. We have 0.5 amps at the input at 50 volts input, delivering nearly 20 watts out. Fan is still off, nearly 10 amps, getting slightly warm now. Capacitor is cool, coil is cool, output capacitor is cool. We raise the voltage to 3 amps now and 1 more to 4 amps, and we have 19.4 amps out. We have an input current of 1.84 amps at 49.9 volts. I adjusted to 50, now exactly 50 at 1.83 amps. And we deliver 76.6 watts. Heatsink is getting slightly warm, maybe 30 degrees. Capacitor is cool, coil is cool, very nice. Let's wait a little bit to watch if the temperature will raise. Oh, the heatsink is only slightly warm. Capacitor is cool. Coil is getting slightly warm now. Maybe, I would say, below 40 degrees. Heatsink maybe 40 degrees now. Letting it run for a little while. So this is really enormous, having nearly 19 amps at the output at only 4 volts. And heatsink is getting a little warm. It's warm at the upper left corner again, interestingly. Coil is getting a bit warm. Input capacitor is cool. Output capacitor is cool. So we have 3.99 volts at the output. This measures 3.924 at a very high current. So this may be some losses. The heatsink is getting warm, but not warmer now, around 40 degrees. Coil is slightly cooler. Input capacitors stay cool. Output capacitors cool as well. So I would say the low voltage high current test passed. Thank you for watching.